The first step when we complete the square is if we do have a coefficient in front of x squared that isn't 1, we have to divide everyone by that number, because in order to complete the square, the x squared term has to have a coefficient of 1. So I go ahead and divide everyone by 2, and this is my resulting trinomial. So now I'm ready to complete the square for real. So now I'm going to subtract the 6 on both sides because I always move over the constant term. So now I have x squared plus 2x equals negative 6. Now it's time for me to actually do the true complete the square step, which is where I take the b, which is really the coefficient of x, I pull it off to the side, I divide it by 2 and square it. Now that number, the answer to that, is going to get added on both sides of the equation. Since 2 divided by 2 is 1 and 1 squared is 1, also I'm adding a 1 to both sides. Okay, so now I'm going to simplify this whole step. So on the left-hand side, I need to turn this trinomial into a binomial squared. And I do that by taking 3 pieces. The x, the sign that's here, and then I go over to the division that I did earlier before it was squared, and that's going to be my third piece. So that looks like x plus 1, since 2 divided by 2 is 1, and this is now a squared binomial. On the right-hand side, I'm just adding, and negative 6 plus 1 is negative 5. Now I'm ready to just solve for x, and the first thing I have to do is get rid of that squared, and I do that by square rooting, which is the opposite. That causes the square root and the squared to cancel each other out, and I'm left with just x plus 1. When I take the square root of negative 5, since there's a negative under the radical, I pull out an I leave it as radical 5, now it's positive, and I always put a plus minus in front of this term, because technically when I solve a quadratic, I should have 2 answers. Now normally, if this number was not a prime number like 5 is, I would simplify it. I would do a factor tree. In this case, I don't have to do that because that is simplest radical form already. So I can continue solving, and I'm going to go ahead and move that 1 away from x. So I end up writing this as plus or minus I radical 5 minus 1, since I can't actually subtract 1 from I radical 5. I could also write this as negative 1 plus or minus I radical 5. These are equivalent. So I am done.